Welcome to JCL Models. I'm Jason, your host, and I do models. It is another episode in our TTL 74LS series of logic chips. This is the 74LS47, the BCD to 7 segment decoder / driver. I have the pinout from the datasheet there. On the right over here is the pinout for the datasheet. Your outputs are here, and your inputs are here, and these are your active low data input and whatnot signals, and I'll go over that on the chip down here. You're going to want to pull them all high if you're going to decode a segment. If you're going to decode multiple, then you're going to look at the data sheet to see what it is. So here is where each of the segments hook up on the right here. This is where they all hook up on the 7 segment display, and then I did this one to show you the different segments because it's a little hard to see on that, but maybe not as hard as I thought. It's harder for me to see it on this screen. So I have it hooked up down here on the circuit. I got a couple things I want to show you with this here. So this looks like a mess. It is a mess. I got this all nice and neat, and this all nice and neat, and then I was like, oh, I gotta run all these switch wires, and I'm like, I'll just use jumpers. So let's get power into this here. My bench has a project on it that I was doing in my free time, so I am going to use my Singlet SDP. Let's get a look at this. My Singlet SPD3303XE, fantastic power supply by Singlet. These are on loan for me for about 2 months. I can have a chance to buy them at the end at a discounted rate. You can support me on Patreon or my GoFundMe to help me purchase this stuff. So we're going to turn on channel 1 at 9 volts and turn our board on. Okay, as you can see, my clock circuit is going because this is why, if you watched my setting up a PC breadboard videos, why I needed this clock up here, a clock pulse, and then this binary counter, because that is how I'm driving the segment display. So if I pulse the clock here and you see it shows 0, let me see if I can make that more visible by doing this. Okay, yeah, that helped a little bit. Okay, so I'm gonna have to, let me see if I can lighten that up. Okay, there's better. You can see it's a little dark, but you can see the LCD of the 7 segment display. So I have it all hooked up. I have those 3 pins, and we'll put it up. I have those 3 pins, LT, RB, RI/RBO, and RBI all tied high. And then I have the A, B, C, and D input coming into my binary counter here. So as I binary counters right there, as I increment this, see there's 1 on the binary counter, and then there's 1 on the display. 2, 3, 4, 5, 6, 7, 8, 9, and this is where it falls up because this decoder only decodes up to 9 because it's a BCD decoder, so it's a binary to decimal, so it's a conversion between binary and decimal. It's not using the hex system, so the next few characters they don't make sense. But I have this hooked up so I can do this right here. Let me pull this one and hook it to this one and this one here. Plug it in there. This one is going to go there, and this one Just gonna go there. Now, I have this set up using some D flip-flops. Check out my D flip-flops. These are 74 LS74s. They're dual D flip-flops, and I'm using them as a toggle switch. So I can toggle 1 in binary up here, and I get a 1. I can turn it off, and I can do a 2. Then I can do a 3. Toggle those both off to get me a 4. And then I can do, there's an 8. And then I can do one more to make a 9. And then I can do a 5. There's a 6. And then if I do something that's not compatible, it glitches out. So it'll go up to 9. That's just 2 different ways that you can use a 7-segment display with you input the number yourself, or you have a program counter that counts it up for you like that does. So that is going to cover it for this video. I'm not going to do any readings or anything. I'm just using basic RC circuits for the D flip-flops. I have a video on making a toggle switch out of the D flip-flops. It's the 74LS74 video. Check that out. I'm hopefully going to release it before this one. So, links, Patreon. Thank you. Have a fantastic day.